where we add one equation to another equation and try to figure out what the meeting point is, if there's a meeting point. Okay, so we'll continue with that and we'll do a substitution method. Okay, so let me just, you guys can see. Okay. The substitution method is, it's the same like this one. You can see the bottom equation is in standard form, which is X business, the Y business, the equal, and then the number. This one is in nothing form, because if it was point slope and slope intercept, it would be Y equals and that stuff. So we can decide if we want to take this to the other side and then solve it, which you are free to do. But this way they want to kind of show you the substitution method, which is usually best to do when you already have an isolated variable, meaning you already have an X equal and all that junk, or you already have Y equals and all that junk. And then you can substitute one into the other. Okay, so let me show you how this works. So this is telling me that whatever X is, it's equal to negative 2Y plus 11. So I can substitute that X value of minus 2Y equal 11 into this bottom equation. No problem. Okay, so I'm gonna do, instead of X here, I'm gonna write negative 2Y plus 11 as my X, and then continue with the minus Y equals 5. And now I have all one equation with just Y's in it. I don't have X's and Y's. I just have Y in it. So I can kind of combine them. So a minus 2Y minus another Y is minus 3Y plus 11 equals 5. And I'll take the 11 to the other side so I can get all my Y's on one side and all my numbers on the other side. And I put minus 3Y equals negative 6. So I divide both of those sides by minus 3 because I just want the Y by itself. I end up with Y equals 2. I would still have to go back and plug in Y equals 2 into one of these equations to see what X is, if I needed the point. But I want to, on the other side, I want to do it the way we did it last week. If we change this to have X, Y, and then the equal sign, it would be X plus 2Y, because I would bring it to that other side, equals 11. This equation would stay the same. And then I would have to see which variable I wanted to get rid of. I'll do the, I won't say the cheap route, but I'll go the easier route and get rid of X because I don't have to multiply anything by the whole equation. I can just change the signs of everyone. So I'll change the signs of everyone on this bottom equation. The plus will now be a minus. This minus will now be a plus. This plus will now be a minus. And I would add these two equations. 11 minus 5 equals 6. 2y plus one more y is 3y. And x plus a negative x, it's gone. So I'll divide both of these sides by 3. And I end up with y equals 2. So I still get the same value for y. Honestly, it's just what your preference is. Like they can't make you solve it a certain way. So if they want you to do substitution, which to me, I don't like that method because I feel like it's a lot of potential to mess up when the minus and the plus and all that stuff. I just would rather figure out the one way that works best for you. And you just can always use that way. Because this is the method from last week, and look, it was less work than this new way that they're trying to show us all this mess. But it's another option. So I have to show it to you. Okay. I'll do another one. And like I said, they would like for you to have this option available when you have already one of the variables by itself on one side. Questions so far? Okay. If I type, can you see it? No. Let me see. Two x plus y equals -4. And x equals y plus 1. So since you have one variable that's already isolated, already by himself, the people that wrote this textbook think that you should use the substitution method, which is substituting this value of x for this x here. So in place of the x in the other equation, I'm going to put this y plus 1. So I have 2 times y plus 1 plus y equals -4. And I'm going to distribute this y into everyone inside the brackets. So 2 times y, 2 times 1, and then I'll try to combine the things that are similar. So 2 y's plus another 1 y gives me 3 y's. And plus 2 equals -4. When I get the numbers on one side and the letters on the other side, -2, -2. I end up with 3y equals -6. Divide both sides by 3. Y equals -2. And then I take my y and I plug it into the easier of the equations. And I substitute now my y value for -2. So I have x equals -2, which is the y that we just got, plus 1. X equals minus 1. So this is a line, yeah? And this is also a line. And when two lines meet, they meet at a point. So my point that they meet, and Weber sign will take off for this, as will I, because you need to know that these are two lines meeting at a point. The answer has to be written like this: minus 1, comma, minus 2. Question so far?
No.
So, next one. Okay, so 2x minus y equals 4, and 2x minus 4 equals y. This one is still set up in an isolated form. We have the y is by itself. So we can use this information to substitute this part into this. So instead of writing y in the top equation, I'm going to write 2x minus 4. So I have 2x minus brackets, 2x minus 4. And I put the brackets because I don't only have one thing for the y. I have this 2x business and the minus 4. So since it's more than one thing, I put it in a bracket so that it just looks cleaner, I guess. And I'll remember to distribute the minus sign. Okay, so now I'm just going to rewrite it without the brackets, but remembering to distribute the minus sign. So 2x minus 2x minus a negative 4 is a plus 4 equals 4. So now I have 2x minus 2x, which is nothing, plus 4 equals 4. And I end up with 4 equals 4, which is great. But I don't have my x, he's gone. So even if I rewrote this and did it like the 2x plus y equals 4 and 2x minus y equals 4, it would still give me the same solution. So do these two lines meet, never meet, or meet too much?
Never meet.
Never meet.
Never meet means that they are,
They're undefined.
let's see, never meet means one line looks like this, and they're just like hanging out like their whole life, but they're never gonna link up and go to the mall.
So
Meet,
they're parallel to each other. That means they won't never touch because they're both positive.
well, see, I don't know, because I didn't get the slope. So if they had the same slope, if you had like a whole bunch of different numbers and you had m equals 2, and then over here you did the line and you did all the work and you still got m equals 2, then yes, that means that they're parallel, and then they will never meet. And this is like the little symbol, maybe it'll show that on the graph. That means that they're parallel. But that's not the case with these. If they were meeting, they would meet at one point, and they would have, their answer would be, 1, -4, or whatever. They would meet at a point. You would actually get a value for X and then be able to get a value for Y. When you end up with something that is true, that means that they met too much. They were not only meeting and parallel, but they were meeting at every point. Every point was the same. And that happens because they're the same line. Because if I move this, if I rewrite the bottom one to be 2x and take the y over to this side, it will be minus y. And take the 4 over to this side, it will be plus 4. That's the same exact thing, 2x minus y equals 4 as this one. It's the same exact line, but you can't put, same exact line as an answer. They want you to put inconsistent or infinitely many solutions. And it's infinitely many solutions because it's too many for me to list out. They're gonna meet at this point, the next one, the next one, the next one, the next one. They're gonna meet at all of the points along the whole line across the whole universe. So they have too many solutions together, which is different from them being the same slope. Because I could have a line over here, just like this, and I can have, like this is my graph. And I can have one line over here and one line over here. And they're the same slope, which you're never gonna meet, but they're not the same line. The same line would be the exact same points over each other. Okay, and that is an option that they have. Questions?
No,
Yeah,
but
no
could we
questions.
do another one? Because I missed like the whole first part.
Okay, no problem. I'm just gonna, instead of trying to make one up, I'm just gonna get one. I'm just gonna. We have these. We have y equals -3 over 2x plus 3 and 6x plus 2y equals 12. Okay, so we want to see if they meet, if they're parallel and don't meet, or if they meet too much and they're the same line. So I'm going to rewrite this one and try to get rid of the fraction. So y equals minus over 2 x plus 3 And I'm gonna, what am I gonna multiply it by to get rid of that 2 on the bottom? I'm gonna get rid of the 2 on the bottom, so I make everyone a fraction. I need to multiply it by 2. Whatever's on the bottom, I'm gonna multiply it by that. So I can get rid of the fraction. So 2 times y, 2y. This will cancel each other. Oh my goodness. This will cancel each other. The 2 and the 2, and I'll end up with 3x, sorry, minus 3x. Two y equals minus 3x plus 2 times 3 is 6. And my equation here is 6x plus 2y equals 12. Since I don't have a variable that's isolated, I don't have a y equals by itself or an x equals by itself, I'm gonna rewrite this into standard form so that I can solve it. So I'm gonna bring the minus 3x to the left side, and it will become a plus 3x plus 2y equals 6. And now you can decide which variable you want to get rid of. Do you want to get rid of the x's, or do you want to get rid of the y's? Oh, you guys are going to talk to me.
The X,
You want to get rid of the x's? How would we need to get rid of the x? I want to do it so that when I add these two, they disappear.
Would you multiply the bottom one by -2?
I didn't hear you say again.
Would you multiply the negative one by the bottom one by -2?
Yeah, the bottom one, I can multiply by -2. So that this becomes a -6x. That way, when I add them, it's nothing. So I can multiply the whole bottom by -2. Or if you see an easier way, you can surely tell me. So I'll leave the top the same. I multiply the bottom by -2. So -6x. -4y. -12. So I have, this is gone. I have minus 2y equals 0. And so when I divide by -2, I have y equals 0. And now I'll go and I'll plug back my y equals 0 into the equation that I didn't mess with and see what I get. So I didn't mess with this one. I'm gonna plug the y equals 0 into this. So I have 6x plus 2 times 0 equals 12, which gives me 6x plus 0 equals 12. And divide both sides by 6. And I have x equals 2. So because I have an answer for x and an answer for y, that means they do meet. And they meet at a point. And my point is going to be 2, 0. Questions? No? Okay.
No questions.
Okay. Well, let's solve these two. X plus y equals 5 and x minus y equals 2. Do I need to do anything to get rid of, well, who do you want to get rid of, x's or y's?
Why?
We'll get rid of the y's because it's already kind of done for us. One is already positive, one's already negative. So I'll just add these together. And I have x plus x is 2x. Nothing is here. Equals 7. So 2x equals 7. I divide both sides by 2. X equals 7 over 2. Sorry about that. And we need to plug in that x equals 7 over 2 into any one of these equations. Since we didn't mess with either one of them, we can plug in 7 over 2 for x into either one you want to see what the value of y is. I'll go with the top one only because the bottom one has a negative sign. Not that I'm afraid, but you know, we want to take the easy route every chance we can. So I'm going to plug in x for 7 over 2. Seven over 2 plus y equals 5. And I'll write my 5 in the form of a fraction because this other guy's in a fraction. Okay. So now I want to get y by itself. I'm going to subtract 7 over 2. Subtract 7 over 2. I have y, because these are gone. Y equals, and when I'm adding or subtracting fractions, they have to have the same bottom number, the same denominator. This one is a 1 and this one's a 2. So I have to pick a new denominator that works for both of them. A number that 1 can go into and 2 can also go into. What is that number?
1.
But 2 doesn't go into 1.
2.
2, okay? It's the smallest number you can think of, but it has to be bigger than the smallest number that you have. Doesn't make any sense, but it has to work for this. 1 has to be able to go into it, and 2 also has to be able to go into it. So now I'm just like changing their names. He's still gonna be worth 5, but he'll just look different. he'll still be worth the same thing because I didn't do anything to him. This is still a -7. Now, whatever I did to the bottom to get this number, I'm gonna also do to the top. So 1 times 2 gives me this 2. 5 times 2 will give me this new number here. So now I have 10 over 2, which is still has the value of 5. Because 2 into 10 will go 5 times. I have 10 over 2 minus 7 over 2. So my answer is going to be something over 2.
Would it be 3/2?
3 over 2. Okay, so my answer is 3 over 2. So I have a point. Thank goodness we're not graphing this. I have a point that is 7 over 2, comma 3 over 2. And you have to write the answer as a point because 2 lines will meet at 1 point. Let's do other ones. But I make sure we're comfortable moving back and forth from slope intercept to standard form and then combining the equations. Y equals 2x minus 5. And y equals- Okay. So y equals 2x minus 5 and y equals 4x plus 3. What kind of form is this equation in? Two choices. It's either slope intercept or yes, good job. Slope intercept or standard. Standard is the ax plus by equals c. So since these are nicely laid out for us, we're gonna go back to the old days where we graph stuff. No graph. Yes, so purple line and this is the okay, so on the blue one, sorry, on the blue one, if this is slope intercept form, right, which is y equals mx plus b. That tells me my y-intercept, and it tells me a slope. So to graph it, I would find the y-intercept, which is my cheap free point, and then I'll use the slope, which is like the graphing GPS, to tell me how to move on this coordinate plane. So for this equation, my slope is here. My slope is 4 over 1. So am I driving uphill or downhill?
Up.
Uphill because my slope is positive. And then this b, it's just a b because I can't use another y. And I don't want to use a letter that you would usually see in an equation. So that's why they use b. It's some random letter that you hardly ever see in equations. So b is my y-intercept, and my y-intercept happens when x is 0. So if x is 0, this is telling me exactly my y is going to be on 3. So that's my free point. 0, 3, I know is going to be on this blue line. So I'm going to go to 0 for x. I'm not going to move left or right. I'm going to go up 3. 1, 2, and that's going to be my dot. And then I'm going to go the way the slope tells me to go. I can go 4 up, and 1 over, 1 to the right. Or I could do the opposite of both of those. I could go 4 down, and to the left 1. And I should still be on the same line. Okay. And then I'm going to do the other equation. Also in slope-intercept form. So y equals mx plus b. And just because the formula is plus b doesn't mean every time you're going to get a positive value for b. It's just a general guide. So for this equation, my slope is 2. Am I driving uphill or downhill?
Up.
Uphill, right? Because my slope
I
is
have a
positive.
question.
Yes.
You said that, how do I say it? So you said we don't always get a positive value, like to add the plus b.
Right.
So if we got a negative, would we add the negative?
Yes, you would add the negative, which is subtracting.
Okay,
So in this one, in this case here, we don't have a plus b, we have a minus b. So this is going to be our intercept, our y-intercept, which happens when x is 0. So my free point is x is 0 because that's the condition I need for the y-intercept to happen. And my y is going to be -5. So my point that the line hits the y-axis will be at 0. And it'll be down here. The action will be all the way down here. -1, 2, 3. Okay. And I'm gonna still use the slope to tell me how to move from my next line. And I know I wanted, that's why I asked you ahead of time, you know your line you're gonna be drawing up. So if you get a point over here that's this way, then you're like, wait a minute, if I connect that, I'm going down, that can't be right. I did something wrong. So I'm here and I go up 2 and to the right 1. Or I could do the opposite of both of those things and go down 2 and to the left 1. Okay. So this is my line for this one. And then I'll try to extend this one. And we don't know where exactly this is on the graph, but now we can figure it out. What exactly is this point? We have y equals 2x minus 5. And y equals 4x plus 3. Wonder if we can use it just like this, since it's still nice, but it's not ax plus by nice. We can change the equation to, sorry, the sign of everyone on the bottom. No, I'll change the equation, everyone on the top. So I can get rid of the y's and see what happens. I'm gonna change this to a negative, change this to a negative, and change this to a plus. And then add these equations. I have negative y plus y, which is 0, nothing. Negative 2x plus 4x, which is the same as 4x minus 2x, which is 2x. 5 plus 3, 8. I need something over here, so I'm gonna move this 8 to the other side. And have minus 8 equals 2x. Divide both sides by 2. So negative 4 equals x. And all of that is just 1/2 of the problem, right? So I know I'm on the right track because I know that this quadrant, which is, that's what this piece of the graph thing is called, the quadrant. This stuff happens here. Pluses for x and pluses for y's. This stuff, this action over here is when x is negative. Oh my goodness, what was I thinking? Negative x and y is positive. This part here is when x is negative and y is negative. This part happens here when x is positive and y is negative. So I know my dot will be here because it's there. So I have x equals negative 4. I'm going to plug that in for this one. So instead of y equals 4x plus 3, I'm going to plug in negative 4 for the value of x. So y equals 4 times negative 4 plus 3. So y equals negative 16 plus 3. So y equals negative 13. So my answer is negative 4, negative 13. Let me stop. Right. Okay, so they're not parallel. They're not the same line. They're just two regular lines. Question so far? I
No.
need to take a break. No, I can do this all day. No break.
Yeah.
Yeah. Take a break. All right. So 5 minutes. Fine.
Can we do another one like this after break? Because
Yes.
I'm not lost.
You want to do one that they don't meet, or just another one just like this? Just
Where they don't meet.
they don't meet. Okay. All right. I'll look for one on break. Okay. So I had a request finally for problems that don't meet. So Let's do this. Oops. Okay, so 3x plus 4y equals 12, and 8y equals minus 6x plus 12. That's not gonna work. Hold on. That's 24. Okay. So I'm gonna rewrite the bottom equation into this standard form. And take the minus 6x over to the left side. So the top remains unchanged. 3x plus 4y equals 12. And the bottom one is now, take my x on the other side, it becomes plus 6x plus 8y equals 24. And who do you want to get rid of, the x's or the y's?
X's?
Okay, so we'll,
No, Y.
y? Okay, so you want to multiply the top equation by minus 2. Multiply the top one by minus 2, so everyone in here is by minus 2. So that leaves me with minus 6x minus 8y equals minus 24. So when I add these two equations together, I have nothing here, nothing here, equals nothing here, which I have 0 equals 0. Great, that's true. But for my lines, that means that they're the same line, that every point on this line is the same on this line. So they're the same line, we write infinitely many solutions. Because too many of the, why are you doing that? Too many of the points work. If 0 equals 0, that's great. That means 1 equals 1 is gonna work, whatever point that is. 2 equals 2, negative 17 equals negative 17. Every single point is gonna work. So every single point is on this line and on this line. Oh my goodness, oh my goodness. Sorry. Okay. Another one. 2x minus y equals minus 8. And y equals 2x. Where's my problem go now? Oh, okay, never mind it open. Just move right. 2x minus 5 equals minus 8. And y equals 2x plus 3. Okay, I'm gonna move around the bottom equation to be in standard form. So I have x, y, and then my number. So the top stays the same. 2x minus y equals minus 8. On the bottom, this 2x goes to the left side, becomes minus 2x plus y equals 3. Now I'm going to add these together. And 2x minus 2x, that's gone. This is gone. And I have 0 equals minus 5. If I want to, I can take this equation because this is slope intercept form, right? Y equals mx plus b. Which means my slope is 2. If I make this equation look like y equals mx plus b, I'll be able to see if my slope is the same. So I'll leave my minus y here. I move the 2x to the other side, which is minus 2x. Minus 8. Slope intercept form says that my y has to be positive. So I'm going to go through and change the sign of everyone. Change this sign, change this sign, change this sign. So now I have y equals 2x plus 8, which lines up with the m is 2, and 2 lines that have the same slope are parallel. That means they're crooked in the same way. So I have a line here. This line will just happen at, let's say my y-intercept would be at 8. So 0, 8. That's that line, slope of pretend 2. And my other one is y equals 2x plus 3. So my y-intercept happens at 3. But they're in the same exact slopiness, the same exact tilt. So they're never going to meet because they have the same slope. So the difference in what you get in the answer is when you're working out, you get 0 equals something, which it's not true. And you're like, I did something wrong, but you go back and you check the slope. So this means that they're the same slope. When you get an answer that is not mathematically correct, that means something is off with these. They're the same slope, but they happen in different places on the graph. Whereas the other one, you get 0 equals 0 or 17 equals 17, which is true, but it's so true, it's always true, which means they're the same line. Make sense? Oh, yeah, me. I understand. Okay. So,
Yes.
All right, thank you. Okay, so we have inequalities and absolute values. So instead of an equal sign, I will now have an unequal sign. So it would be like, and then you can, no, say we have minus 6x plus 33 is less than 15. Why are you doing that? Okay. So we want to graph this on just a number line because I don't have an X and a Y. So it's not a line. It's just a regular kind of, this is this part of the line. Okay, so it's a number line and I would do 0 someplace. You get the idea. And this is the negative side. So I want to see what the value of X is, excuse me, and how I can graph it on this number line. So I have, it's the same concept. I'm going to put my X's on one side and my numbers on the other side. So minus 33. Minus 33. I have minus 6x is less than minus 18. I don't know.
18.
Minus 18. And the thing is with the inequalities, you have to remember this is like a big thing. Like this like will ruin your life. If you, hold on, let me try to erase this. When you divide by a negative, I'm going to type this out. When you divide by a negative, you have to switch the sign. Okay, so when you divide by a negative, you have to switch the sign. Because that's like me doing the opposite of the opposite.
So if we wanted to divide negative 6x by both sides, we divide it by 6x.
No, you would divide it by negative 6x. You still get the same answer. So you'll divide it by negative 6x, or negative 6, sorry. But this is the sign that you have to switch this sign. So now instead of less than, it's greater than.
Oh, okay.
So X is greater than 3. And then to put that on the graph, this is my 3, okay? So 1, 2, 3, this is my 3 here. So to show that X is, they have some graphs do this, like an open circle or a circle, and some do open parentheses. I don't know which one yours does, but this shows that it is everything greater than 3, but not 3. It's not greater than or equal to 3. It's just 3.01, 3.02, 3.7. It's everything bigger than 3, but it does not include, does not include 3. So I have to have an open circle, like an open whatever, and my arrow goes to the right. And some graphs would have an open parentheses and to the right. That shows that it doesn't include, your answer doesn't include 3, but everything just to the right of it.
So for the closed circles, is it like when it's equal to?
Yes, when it's less than or equal to. Exactly. Because that shows that that is an answer and everything to the right or left of it. Okay, so 2x plus 11 is less than or equal to 3. Can I underline here? Oh. Zoom doesn't let me do less than equal. Come on now. Good job. Now that's tacky, huh? That's pretty tacky. But 2x plus 11 less than or equal to 3. When you have one variable, you'll have one just a line to graph. Okay, so I'm gonna do it the same way. I'm gonna move over the 11 to the other side. Leaves me with 2x less than or equal to 3 minus 11. Three minus 11 is minus 8.
Oh,
What are you gonna say? That's not right. It's still early. I give you a pass. It's still early. Divide by 2. Have x less than or equal to -4. So on this number line, which is just the x part, this is just the x part of the graph. The y would be here if we were doing 2 at the same time. So I find -4, -1, -2, 3, -4. And I want to color it in to show that 4 is also a solution. And everything to the left of it. And instead of open parentheses, we would use the brackets. Which is a little like English, you know, forcing their way into our math stuff, but. Okay, they use the hard bracket to show that -4 is also a solution and everything to the left of it. Okay. I'm doing this. -1/4 x minus 7 is greater than -9. Only one variable in there. So that means just a number line, a single number line. So -1/4 x minus 7 greater than -9. I'm gonna move the -7 over to the other side. Give me a +7. Have -1/4 x. It's gone, is greater than -2. So I'm gonna divide by -1/4. Divide by -1/4. Divide by -1/4. So I have x, and I need to flip my sign. When you multiply or divide by a negative, you have to change the symbol. So I'm dividing by a negative. You change the symbol, so now it's x less than. And I have, I'm so sorry for this. No, I'm not really sorry for this, but we need to practice these. So -2/1 divided by -1/4. When you divide a fraction, you flip the second fraction and multiply instead. So I have -2 times 4, -8/1. So I have equals -8. So x is less than -8. I go to my number line. 2. 6. 8. Is it gonna be a open dot or a closed dot? Color it in or leave it open? Did I lose you?
No.
Open.
Open. I remember it like if I have an extra line here, then I have to do extra lines of coloring. So it's open and it's, my line will go to the left because it wants to be smaller than -8. And if it was with the brackets, it would be a bracket like this. Smaller than -8. Okay. Okay.
Can we do another one like that?
Oh, sure, I have loads of them, huh? So this is weird. I feel like I don't know why we'd ever need to be doing this, but all the explanation I got is that they use this in electricity, which I'm never gonna be doing, so why do I need to know how to do this? Less than equal to -1. So 2 -2/5 x minus 2/5 x plus 3 is less than or equal to -1. So I'm going to do something a little different. I'm first gonna multiply everything by 5 because that fraction is it's too much for me right now. I'm gonna multiply the whole inequality by 5. which is gonna get rid of this fraction here, and I'll have a minus 2x plus 15 less than or equal to minus 5. And now I will move around myself. I move the 15 to the right side. So minus 15. Minus 15. And minus 2x. That's gone. Is less than or equal to minus 20. I want to get x by itself, so I'm going to divide away the -2. Anytime I multiply or divide by a negative, I change my sign. So I'm going to change my sign before I do the work because I'm old and I may forget. So now I have x greater than or equal to 10. Line. So 2. Open or close circle. Open or close circle. No, all right. Because it is greater than or equal to, I'm gonna color in the circle. It's gonna be closed. And if it were a bracket that I was using, it would be a hard bracket because a hard bracket shows that 10 is a solution and everything greater than 10 is also a solution. Okay. Note here that a literal a literal equation is one where the missing variable or the value represents something that's real, something that you know. Time, interest, distance, slope is a literal equation. Okay, so you may see that on the homework. Okay, so let's see, 2x plus 1 less than 7x plus 6. This is not a trick. I can put more than one thing on one side, more than one thing on the other side, but I still only have x's. So you're still working at the same way. You want to choose what side you want the x's to be on what side you want the numbers to be on. And this one, I'm gonna choose, since you guys aren't talking to me anyway, I'm gonna choose to put my x's on this side because I don't want to deal with a negative number. So when I move this minus 2x here, I want to still have a positive value for x. So I end up with 1 is less than 5x plus 6. And now I'm going to move this 6 over to this side, the left side. Minus 6. Minus 6. I have minus 5 is less than 5x. Want to get x by itself, so I divide away whoever's next to it. Divided by 5, both sides. Minus 1. And now I can just kind of just flip the thing like this. So if minus 1 is less than x, then x is greater than minus 1. I mean, it looks like more normal that way. Okay, as long as I have the opening side, which is it next to the same stuff. The order doesn't matter. So I put it on a line. Zero. -1. X is going to be greater than minus 1. Is it going to be open or closed, colored in or left blank circle? Oh yes, me back there, you in the back in the red shirt. Good job, you. Okay, so I have left it open. That doesn't include -1 as an answer. It's just everything bigger than -1. If it was using brackets, it would be an open bracket, so it does not include -1 and everything to the right. You with me? How many of myself? No, it's okay. Okay. This is a big one. Let me see. Oh. -1/4 times 12x minus 72 is less than or equal to 1/3 times 6x plus 24 minus 20. Perfectly legal question. It just has a lot of stuff.
Okay,
So-
this sounds like a really big question.
Yeah,
Well, equation. I was
Yeah.
gonna say, so for this one, how would we like isolate it, I guess? Because you know how we subtract?
yeah. You have to before you start subtracting and moving things over left and right, you have to kind of clean it up.
Do we have to do PEMDAS for this equation?
Well, you could multiply 1/4 by these things as long as they're divisible by 4. Or you could take the whole thing and multiply it by a number that works for 3 for your problem. Like you focus on the problems. The problem is, oh my gosh, I have a fraction here, and I have a fraction here. So your problem is that you have these two fractions. So you could multiply the whole thing by a number that 4 can go into and 3 can go into to get rid of the fractions. The smallest number you can think of that 4 will go into and 3 will go into.
So 12.
12. So I'm going to multiply the whole thing, but like really slowly so I don't mess up. There's a lot of stuff here. 12. So 4 will go into 12 3 times. 3 times minus 1, minus 3. Twelve times 12, this gives me just X, right? Okay, I don't need to. Since this is in the brackets, I only need to multiply what's outside of the brackets. If that makes sense. Because the brackets is like a force field, like a protective force field. So these are my only the things out of the brackets are what I'm going to multiply the 12 by. So I'm going to leave this. As a 12x. Now 3 will go into 12 4 times, and 4 times 1 is 4. 4 here. Leave these like this. So 12 times 20, 240.
40. Would it be a negative, right?
Yes, negative. I keep whatever sign is in here because this one was positive 12 again. So now that the fractions are gone, I can multiply these things through here. So minus 3 times 12x is minus 36x. Minus 3 times minus 72 is plus 210, 216. 72 times 3. 216. Yeah, 216. There's 216. Less than or equal 4 times 6, 24x. Plus 4 times 24, 96. And minus 2. Minus 240. Okay, so on this side, I can combine the 96 and the minus 240. When you 4x, what is 240 minus 96? And then my answer will be negative. And 44 minus 144. And then I'll put 36x to the right side with the 24x. So plus 36x plus 36x. So I have 216 less than or equal to 60x minus 144. And I'll take the minus 144 to the other side. Plus 144. Plus 144. $360. 360 is less than or equal to 60x. I want to divide both sides by 60. $60 goes into 360 6 times. 6 is less than or equal to x. My number line. 6, 0, 1, 2, 3, 4, 5, 6. Is it open or closed circle?
Closed.
Closed. Closed because my answer includes 6 and everyone larger than 6. If it were a bracket situation, it would be a hard bracket and to the right. That was a little unfair, but I can't get you to practice fractions unless I actually make them up, so. Questions so far? No questions since that's the end of the time.
No.
Okay. Well, alrighty then, have a good weekend. I will post more homework as usual.
Thank you.
Alrighty. If you have questions, I'm still here.
Hey, Miss.
Have a great one.
All right, you too.
For the test.
Bye,
that we
miss. Have a
had-
good holiday.
Okay. Oh, yes. Oh my gosh, thank you.
For the test that we did on Monday and throughout the weekend.
Can hear you?
I'm sorry, can you hear me?
Yes, I can hear you. Go ahead.
Okay. I sent you the graphs through text message, but I don't think you got them. Could I double check I got the right number?
Okay, let me see.
We have class Monday, right?
No, Monday is Labor Day, right? No class Monday,
Okay,
but I will still post homework. I
okay.
didn't forget about it. Okay,
I'll see you on Wednesday.
all right, take care.
Have a good one.
You too.
That was the question I was gonna ask too,
Oh.
but
Yeah,
yes, see you Wednesday.
all right, see you Wednesday. I don't see. Oh, yes, true. Okay, all right, I see that. It went to my junk, sorry.
Okay.
Okay,
So you
I'll
check-
look at them and then I will. 6 for those. Okay, I will look at it and I will respond.
All right, thank you. I appreciate
Okay,
it.
no problem.
You have a good weekend.
You too.